Students, welcome back to the second class on integration by substitution. As I've already told you, this is a very important chapter. So today, last class I explained the concepts, the steps to integrate by using substitution. Now we are going to elaborate on that topic by, I'll give you some examples to explain and understand better. So this is page number this is page number 348, 348, exercise 11, subdivision 2. So we start with question number 7. Question number 7, subdivision 1 is integration of 2x plus 5 dx divided by x square plus 5x plus 7. So as you can see, the first thing you need to see is, look at this, how many functions are there? There are two functions. So I told you we are going to use substitution. Substitution means we are changing x to z so that the question gets converted into standard form. So what is rule number 1? Whenever there are two terms, we differentiate the denominator first. Differentiate this and see whether you get the numerator or not. X square is 2x and 5x is 5. Yes, 7 is 0. So the assumption is correct. So this is how you start. So let x square plus 5x plus 7 equal to z. Differentiation of x square is 2x plus 5. Differentiation of x is 1, 7 is 0, and z is dz by dx. Now this dx we are going to write, we are taking it to the left. So from next time, after I differentiate, I'm not going to write this step, I'm going to write dx. So you have to understand that from where are you getting dx. So dx equal to dz. So the last and the first substitution is very important. So the last one, so 2x plus 5 dx. So instead of this 2x plus 5 dx, I can write dz divided by, instead of x square plus 5x plus 7, I can write z. So don't you see that this has been converted into the standard form? So what is integration of 1 by z? It is nothing but log z plus c. So log, what is the value of z? Is the value of z, put the value of log inside modulus. So log modulus x square plus log mod z. So log modulus x square plus 5x plus 7 plus c. So this is how you integrate by using method of substitution. So the entire questions are to be done in a similar fashion. The questions which I am leaving it, this is for you to try at home. So question number 7, subdivision 4, it's integration dx divided by x log x. Now please don't forget the criteria which I was talking about. Out of two functions, you have to take one as z, which on differentiation will give us the other. So you can see two functions, one is x, the other one is log x. Now please tell me, what's the differentiation of x? Differentiation of x is 1. Are you getting 1? No, you're supposed to get log x, isn't it? So you can't take x as z. Now next, log x. What is the differential log x? 1 by x. See, we can take 1 in the numerator and x in the denominator. So that means when you differentiate log x, I'm getting 1 by x. So let, again the same process assumption, let log x equal to z, differentiation 1 by x. After I differentiate, what did I tell you to write? Dx, and differentiation of z is dz. I hope now you understood from where you are getting dx. It's dz by dx. So dx comes up. So 1 by x dx equal to dz. Now substitute. Step number 1 is assumption, step number 2 is differentiation, and step number 3 is assumption. So look for 1 by x dx. So 1 by x dx, instead of this 1 by x dx, what can I write? Dz in the numerator divided by log x is left, log x is what? Z. Again, isn't this the standard form? So what is integration of 1 by z? It is log modulus z. The moment you remove the integration sign, plus c, you get integration constant. So log modulus, what's the value of z? It is log x plus c. So this is how you solve it. So this is question number 7. So the remaining question 2, 3 and 5 can be easily done. So next, question number 8. Question number 8, subdivision 3. Question number 8, subdivision 3. The question is integration 2x plus 5 dx divided by cube root of x square plus 5x plus 7. 5x plus 7. Okay, now look at this again. Don't you see that it's a fraction? it's a fraction, so you know that one part has to be assumed as z, which on differential will give us the other. So rule 1 says go for the fraction. So don't you see that x square plus 5x plus 7 is the fraction out here, the denominator? Differentiate that, you are bound to get the numerator. So this has to be taken as z. So let cube root x square plus 5x plus z equal to 5x plus 7 equal to z. You remove the cube, so what do I write? Cubing both sides, so you get x square plus 5x plus 7 equal to z cube. Now step number 2, differentiation. So 2x plus 5, differentiation of x is 1 and 7 is 0. So after differentiation I told you to write dx, and what's the differentiation of z cube? 3 comes in front, so you get 3 z square dz. I hope you understood till here. Now again do the same thing, same process, substitute. So instead of 2x plus 5 dx, what can I write? 3 z square dz divided by, instead of cube root of x square plus 5x plus 7, what can I write? Z. So as you can see, the moment you substitute, the entire question changes from x to z, and automatically it gets removed to standard form. So 3 is a constant, z and z gets cancelled, so you are left with what? Z into dz. And don't you know the integration of z? Remember in the first class I told you, in differentiation the power decreases, integration the power increases. So 3 as it is, what is the integration of z? It is n plus 1 divided by n plus 1 plus c. That means 3 z square by 2 plus c. So put the value of z, 3 by 2, what's the value of z? Cube root of x square plus 5x plus 7 whole square plus c. So this is your final answer. So this is how you use the steps to solve a question on substitution. Before I move on to the next question, because all the questions we are going to solve in a similar fashion, so I'll just tell you what are the basics you need to know. Every time you come across two functions, one function has to be taken as z. Why are we substituting? Because in integration there is no quotient rule or product rule. Is that clear? So what we do is we convert two functions into one, so that we can directly apply the formula of integration. Understood? So this one was question number 8, subdivision 3. Now I want 8 subdivision 3. Now question number 8 subdivision 7. Cos open bracket log x by x dx. Now look at this question. So rule number 1 says denominator, but it's not what do you call a short rule. It's just a criteria. It's just a what do you call guideline. So differentiate x. Do I get cos x? No. That means when you differentiate x, you are not getting cos log x. So rule number 1 fails out here. So rule number 2 says go for the composite part. Composite means cos should always be with x, isn't it? But it is log x. So assume log x as z. What's the differential log x? 1 by x. I can assume 1 in the numerator, no problem. So in this case, the rule 2 works to find out z. That is the composite part. So let log x equal to z. So differential of log x is 1 by x dx equal to dz. I hope there is no confusion regarding dx. From where did you get this? dz by dx, so dx comes up. Is that clear? So now substitute. So instead of dx by x, what do I get? dz, and only cos log x is left, and cos log x is z. So isn't this the standard form? So what is the integration of cos? Integration of cos, differentiation of cos is minus sine z. So integration of cos is sine z plus c. So sine as it is, what is the value of z? It is log x plus c. Don't forget to substitute the value at the end. And don't forget to write c. And after you write c, please, one thing I forgot to tell you, please write c equal to IC, where c stands for integration constant. If you don't do this, you will lose marks. So this one was question number 8. Question number 8. In a similar fashion, you all can try the questions, the remaining questions, and don't worry, I'll be sending you the PDF of the solution of all the questions of this particular exercise. But before you look at the solutions, you try on your own. If you have any problem, then only you look at the solutions. Is that clear? Okay. Now next, question number 9, subdivision 1. Question number 9, subdivision 1. Integration x square into cos x cube dx. Now rule number one, if it's a fraction then you take the denominator as z, but out here there is no fraction out here, so go for the composite part. Cos is always with x, isn't it? But this is x cube. So think about this. When you differentiate this, do you get this? Yes, because x cube is what? 3x square. We are getting the constant. We are getting the function. The constant does not matter out here. So let x cube equal to z. So differentiate of x cube is 3x square. After you differentiate, what you are supposed to write? Dx. Z becomes dz. So look at the question. X square and dx is there, but 3 is not there. So remove that. So x square dx will become dz by 3. Now substitute the last one and the first one. So instead of x square and dx, what can I write? Dz divided by 3, cos as it is, and instead of x square I can write x cube, I can write z. So 3 goes out, so becomes 1 by 3 integration cos z dz. So 1 by 3, what is the integration of cos z? It is sin z plus c. So 1 by 3 as it is, sine, what is the value of z? It is x cube plus c. So as you can see, all the questions we are using the same concept again and again. Is that clear? Okay, next question number 9, subdivision 4. This is an ISC question. So you got dx divided by x plus root x, x plus root x. Okay, now look at this. There are two terms. So we are going to take x, because what's the differentiation of x? Differentiation of x is 1. So but there is a square root. So take that so that the solution becomes simple. So let root x equal to z. Why have I taken root x as z? Because differentiation of x will give me 1. But there is no root. Remove the root, squaring both sides. So what do you get? X equal to z square. Now differentiate. Differentiation of x is 1. After differentiation, what did I tell you to write? Dx, and differentiation of z square is 2z dz. Now substitute. So instead of dx, what can I write? 2z dz divided by, instead of x, what is x? It is z square, and what is root x? It is z. So 2 is a constant, goes out, you get z dz divided by z is common, so you get z plus 1. Z and z gets cancelled, so you are left with 2 integration. There's nothing in the numerator, means 1 divided by z plus 1 dz. Can anyone tell me what is the integration of 1 by x dx? It is log x, isn't it? In a similar way, integration of 1 by z plus any constant will also be log. 1 by z is log, so 1 by z plus another constant will also be log of that. So log modulus z plus 1 plus c. So your final answer, 2 log modulus, what's the value of z? Z is root x plus 1 plus c. So this is how you solve this particular question. This one was question number 9. Is that clear? Okay. Question number 9. Now look at question number 11. Question number 11, subdivision 2. 11 subdivision 2. The question is integration 1 plus sine 3t whole cube into cos 3t dt. So this was the question. So look at this. Again, there is no fraction, no denominator. So we have to look for a composite part. Composite means if the power is a constant, the base has to be x. Remember x to the power n type, yes. So think about it. Differentiation of 1 is 0 and differentiation of sine is cos. That means you are getting it. If you are having problems understanding the composite part, then differentiate one function at a time, and if you get the other, then take that as z. For example, if I think that cos 3t should be taken as z, so what is the differentiation of cos? It's sine, but you are supposed to get 1 plus sine 3t whole to the power 3. That is, you are not getting that. That is why we are not taking this as z. So let 1 plus sine 3t equal to z. Differentiation of 1 is 0. Sine mx, 3 comes in front, so differentiation of sine is cos. 3t. After you differentiate, I told you to write dt, and z is dz. I hope you understood. Again, you are understanding how you are getting dt. You are differentiating with respect to t, so you get dz by dt. So just to avoid one step, I've written it directly. So look at the question. Cos 3t dt is there. What is not there? 3 is not there. So cos 3t dt will be equal to dz divided by 3. Now put the value. So what is cos 3t dt? The last one, it is dz by 3. And what is 1 plus cosine 3t? It is z to the power 3. So one observation which you can make out here is, the moment we use substitution means change x to z, automatically the question gets reduced to standard form. And haven't you seen this formula? Integration of x to the power n dx is power increases. So n plus 1 divided by n plus 1. So 1 by 3 as it is, integration of z to the power 3 becomes 3 plus 1 is 4 divided by 4 plus c. So your final answer is 4 3s are 12, and the value of z is 1 plus sine 3t all to the power 4 plus c, where c equal to IC. Don't forget that. So this one was question number 11 subdivision 2. 11 subdivision 2. 11 subdivision 2. Now we are going to do question number 11 subdivision 6. Integration cos x dx divided by root 1 plus sin x. Now look at this. Doesn't this look like a fraction to you? Yes. Now whenever you see a fraction, differentiate the denominator, not the root, just the function. Differentiation of 1 is 0, sin x is cos x. You are getting it. That means the assumption is correct. So let root 1 plus sin x equal to z. But you are going to get the function only if the root is not there. So that is why we square both sides. So what do you get? 1 plus sin x equal to z square. Differentiation 1 is 0, sin x is cos x dx equal to z square is 2z dz. Now substitute. So instead of cos x dx, what can I write? 2z dz divided by root 1 plus sin x. What is that? Z. So 2 comes out, into z and z gets cancelled. Now isn't this the standard form? Please tell me which formula is this. Formula number 5, integration of dx is x plus c. So integration of dz is going to be 2 is already there, so 2z plus c. So 2, what's the value of z? It is root 1 plus sin x plus c. So this is question number 11 subdivision 4. Time. Okay, 11 subdivision 5. Integration x square dx divided by cos square x cube. 11 subdivision 5. I'm so sorry, the previous one was 11 subdivision 6. Okay, look at this particular question. Okay, now as you can see, cos is in the denominator, but I can't take cos as z, because in order to take cos as z, there has to be sine in the numerator. Because what is the rule? You take such a function as z, which on differentiation will give us the other function. That's the only rule which you need to keep in mind. And in order to make it simple, I've made it very easy for you to select z by using the two rules which I have taught. Number one is if it's a fraction, the denominator, and if the rule number 1 does not work, then you go for the composite part. So I can clearly see out here I'm going to use the composite part. Cos should always be with x, isn't it? So let x cube equal to z. So differentiation of x cube will give us 3x square dx equal to dz. See, until getting x square, 3 is extra, so x square dx will be equal to dz divided by 3. Now put the value of x square dx. What do you get? X square dx, you get dz divided by 3 divided by cos square z. So 3 is a constant, comes out, so integration of 1 by cos square z dz. So see, you successfully converted x to z, and in doing so you have converted this into a standard form. So since trigonometrical ratios, we can take it up. Reciprocal of cos is what? Sec square z dz. And don't you know that there's a formula for sec square z? It is tan z plus c. So your answer is 1 by 3 tan, what's the value of z please? It is x cube plus c. So this is question number 11 subdivision 5. Question number 11, subdivision 5. Okay. Now question number 12, subdivision 2. Question number 12, subdivision 2. It's integration e to the power x 1 plus x into sine x dot e to the power x dx. So out here, can you tell which is the composite part? Sine should always be with x, isn't it? So let x dot e to the power x equal to z. But the problem out here is when we are differentiating, what rule should we apply? Think for a moment. Okay, so how many of you got it? This must be product rule. So what was product rule? U d by dx of v plus v d by dx of u equal to z is dz. So what do you get? X as it is, differential of ex is ex, ex as the differential of x is 1. After you differentiate, dx equal to dz. What is common? E to the power x is common, so x plus 1 dx equal to dz, and you will see that automatically that is there in the numerator in the question also. So instead of e to the power x 1 plus x dx, what can I write? Dz. Always write dz at the end. So you are left with sine x ex is z. So integration of sine z is minus cos z plus c, so equal to minus cos, what's the value of z? X dot e to the power x plus c. So this is how you solve question number 12, subdivision 2. Is that clear? This one was question number 12, subdivision 2. Question number 12, subdivision 4. 12, subdivision 4. 12, subdivision 4. The question is e to the power x plus 1 by x, open bracket, x minus 1 by x square dx. Again, there is no fraction, so go for the composite part. E should always be with x. So this is just an assumption. You just differentiate mentally and then only you proceed. Okay, because if for this to be taken as z, I'm supposed to get this, and I'm getting it. So what is the differentiation? Please tell me. Differentiation of x is 1 and 1 by x is minus 1 by x square dx equal to dz. Now please put in the values. So so instead of these two, what can I write? Dz. So instead of e to the power x plus 1, what can I write? Z. So integration of e to the power z is e to the power z plus c. So e to the power, what is z? X plus 1 by x plus c. So this is how you solve questions on substitution. Once again, my dear students, please listen to me carefully. This method of substitution is very important for you all because most of the questions are to be solved in a similar fashion. So page number 349, I want you all to try all the questions. If you have problem, don't worry, I'll be sending you the PDF of the solutions of all the questions individually, and if you still have problems, you can text me or WhatsApp me. I'll explain it to you by sending a separate video on that particular question also. Is that clear? So before I just round off this particular exercise, I'll just tell you the basics. You will see two functions either being multiplied or being divided. There's no product rule, there's no quotient rule, so we substitute. What is substitution? Change x to zy. So when you do that, it automatically changes into standard form. Understood? And for that you need to take 1 as z. And what is rule number? What are the rules to take a particular function as z? Rule 1, if it's a fraction, the denominator, and if rule 1 fails, then you take the composite part. Thank you so much.